Hey guys, get ready to strap in. This is a lesson that you're going to have to pay close attention to. We're going to take a lot of things that we've already learned and kind of put them together in new and different and more complicated ways. Alright, so we're going to solve polynomial equations. So our objectives are, we're going to answer the question, how can our understanding of solving quadratic equations help us solve polynomial equations? So we're going to do that by factoring, and we're also going to do it by graphing. And I'm going to teach you some other patterns to look for with polynomials in order to factor them. So what are the real or imaginary solutions of each polynomial? First we're going to start with 2x cubed minus 5x squared equals 3x. Okay, the first thing that we always want to do when we have polynomials is put them in standard form. So we're going to subtract 3x from both sides. And then you notice that all three of these terms have an x in them, so let's go ahead and factor out that x first. So we have 2x squared minus 5x minus 3, and then let's see if that's factorable. Multiples of 2, multiples of 3 that we rearrange to make 5, and we can factor that as 2x plus 1 and x minus 3, and then we can just use our zero products property, set each one of these equal to 0. So x equals 0, 2x plus 1 equals 0, and x minus 3 equals 0. So here we have x is 0, add 3, x is 3, and then we subtract 1, divide by 2, we get x is negative 1/2. And those are our three solutions, which we should have three solutions because of the power. Alright, this one, 3x to the 4th plus 12x squared equals 6x cubed. So again, the first thing we want to do is we want to write it in standard form, so subtract 6x cubed from both sides. And also divide it by 3 because they all have factors of 3. So then this, we can take an x squared out of everything, and that leaves us with x squared minus 2x plus 4. Now, is x squared minus 2x plus 4 factorable? It is not. So we're going to have to put it into the quadratic formula. So x equals 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 4 over 2 times 1. Okay, and then we simplify 4 minus 16 over 2. 2 plus or minus the square root of negative 12 over 2. Now negative 12 we can rewrite as square root of negative 4 and square root of 3. So we get 2 plus or minus 2i square root of 3 over 2. And all of our coefficients are 2's, so they're reducible. So 1 plus or minus I square root of 3. Those are two of our solutions, and then we get our other two solutions here by squaring x squared equals 0. So then you have 2 zeros. So those are our four solutions for our quartic. Alright, and then this one's already factored for us, so we can set each factor equal to 0. So x squared minus 1 equals 0, and x squared plus 4 equals 0. Add 1. Subtract 4. Oops. So x squared equals 1. Square root of that is 1 and negative 1. And then x squared equals negative 4. Square root of that is 2i and negative 2i. So there's our four solutions for that one. So not too much new so far, just, kind of using the skills that we've already learned, putting them together. Alright, so here are some factoring techniques that you're going to want to be aware of and take note of these. So you can start by factoring out the greatest common factor. So if you have something in common with all of your factors, take that out first. It's going to make your life a little bit easier. If you have quadratic trinomials, you can factor those. That's the way that your book explains it, and it's kind of complicated, so don't worry about it. Perfect square trinomials, which we've already talked about. Those are if you have the a plus b quantity squared, how to rewrite those. We learned those when we did completing the square, adding or subtracting. Difference of squares, when you subtract two squares, you get the square root of each one, a positive and a negative root. Factoring by grouping. This is new. So a lot of times when we have four terms, you can rewrite them as groups of two and find out what those two groups have in common, and then factor those. So for example, this one, I'll take a second to explain. So what you do with these is you factor like this group and this group together, and you see that this group has x squared in common, and that leaves x plus 2, and this group has negative 3 in common, which leaves x plus 2. Do you notice that these are factors? So this is one of our factors, x plus 2, and our other factor is what's remaining, x squared minus 3. Oh, I forgot the squared on that. Oh no, it's just x. Yeah, x squared. So there should be an x squared there. And the sum or difference of cubes. This one is just kind of tricky, and you're just going to have to learn it. So if you have a cubed plus b cubed, one of your factors is a plus b, and your other factor is a squared minus ab plus b squared. So here's one of those, 8x cubed plus 1. So you take the cubed root of 8 is 2, so 2x plus 1, cubed root of 1 is also 1, and that leaves you with 4x squared minus 2x plus 1. Or if it's subtracting, the only thing that changes is, so if it's plus and then minus. If it's minus and then plus. And then they're always, the last one is plus. So make sure you get familiar with those, learn those. They're going to be very helpful to you. Alright, so let's find the real and imaginary solutions of the polynomial. So we have x squared minus 3x squared equals 4. I'm going to go ahead and take out, subtract the 4 to both sides. And then in this case, since I have an x to the 4th and an x squared, I'm going to say x squared equals a to make it easier for me to factor. So I'm going to rewrite this as a squared minus 3a minus 4 equals 0. This is just for the purpose of factoring, to help us be able to see things a little more clearly. So I can rewrite this as a minus 4, a plus 1. Easily factorable, totally understandable. Okay, when we get to this point, when we rewrite it as factors, we're going to take and replace that a with x squared. So x squared minus 4 equals 0, and x squared plus 1 equals 0. And then we can add our 4. So x squared equals 4, square root, x equals 2 and negative 2. This one, subtract 1, x squared equals negative 1, square root, and I also get I and negative I. So this is just for the purposes of factoring, in order for us to better see relationships, to make it easier for us when we do factor. That's just explaining all of what I just did again. And we can also check by graphing. So why don't you go ahead and try this one. X cubed equals 1. Now remember, we want to put it in standard form first, so subtract 1, and then use your cubic rules in order to solve. Okay, so hopefully you paused the video like you were supposed to. We're going to subtract that 1 first. So I get x cubed minus 1 equals 0, and then we're going to use our difference of cubes rule. Rewrite it as x minus 1 times x squared plus x plus 1 equals 0. Alright, and then x squared plus x plus 1 is not factorable, so we need to use the quadratic formula just like we did before. And then you find that your solutions are 1 because of the x minus 1 equals 0. And then we also have negative 1/2 plus I square root of 3 over 2, and negative 1/2 minus I square root of 3 over 2. You can write them like that, or you can also write it as negative 1 plus or minus I square root of 3 all over 2. That's another, both are acceptable ways to write them. I think Math Excel wants more like this way, but I think they might put like the I at the end. I don't really know. Whatever. Math Excel is just very picky. Okay, and then x to the 4th equals 16. Let's go ahead and do that one. We want to start by subtracting 16 on both sides. So x to the 4th minus 16 equals 0. I'm going to rewrite x squared as a. So I get a squared minus 16 equals 0. So I have a plus 4 times a minus 4 equals 0 using my difference of squares. And then I'm going to reset each one again. X squared plus 4 equals 0. So subtract 4. I get x equals plus or minus 2i. And then x squared minus 4 equals 0. So add 4. So x equals plus or minus 2. So there's your 4 solutions for that one. Alright, I think we've done enough of these. You kind of get the point. So, finding real roots by graphing. So what are the real solutions of the equation x cubed plus 5 equals 4x squared plus x? So what you're going to want to do is, we have two different ways. You can either take and set each part, so this one as your y1 and this one as your y2, and then graph them both and see where they intersect, and those will be your solutions, because we want to see where they're equal to each other, right? Equal. So where they're equal to each other. So go ahead and put those into your y1 and your y2. Hit graph, second calc, and it's number 5 is your intersect, and you just have to do each line and then look for all the places where they cross. And I got negative 1.09, 1.16, and 3.93. So make sure you're looking for all the solutions. There should be 3 solutions because, or up to 3 solutions, because we have a cubic. The second one is we can rewrite it as in standard form and then graph using the 0 feature. So when you go ahead and hit graph, you can see where it crosses the x-axis. So those are our solutions. So when you do second calc, number 2 is your 0. Those will give you solutions, and they'll give you the exact same answers. And then once you've found your solutions, go ahead and check and verify that they satisfy the original equations. So plug in those values for all of your x's and check to make sure that they're either really close or really or exact. I mean, sometimes they'll be exact, sometimes they'll just be really, really close, because we have to do rounding and stuff. Alright, so why don't you go ahead and try this one, find out what, from either method that you like, find out what the real solutions are of this equation. I only found one real solution, and it's that x is negative 1.84. So we have a possible of 3 solutions, so that means 2 of them are going to be imaginary. Alright, and then modeling a situation. You can go ahead and read through this one. We're kind of running out of time, but this is just like a story problem. Have you ever had those really crazy problems and they want you to find really weird things? Okay, so this is kind of that same thing. So they want you to find out the ages of each one on a specific day with the given information, and the sum of the ages equals the products of the ages. So then you have to either solve either way by putting them in as 2 separate equations, finding where they intersect, or putting them in standard form and finding their zeros. So it's the same thing, just using specific information. So here's your lesson check. I want you to solve the first one, and then also I want you to see if you can find out the solution of the second one and compare these two with your partner when we get to class on Monday. And there's your homework, and have a great weekend.